Okay, this is one of the problems out of the book. I'm going to analyze the circuit and find the current and voltage everywhere. I've went ahead and made a chart up, and I labeled my resistors and filled in the resistances in the chart. Now I'm going to start drawing equivalent resistances. Alright, I know I'm going to take R5 and R6 and combine them since they're in parallel and call that EQ1. I'm going to take R3 and R4, combine them since they're in parallel, and call that EQ2. Okay, I've used the formula for finding equivalent resistance of resistors in parallel, which is 1 over the sum of the inverses of the resistances. So for EQ1, I have 1 over 6 plus 1 over 6 gives me 3. And for EQ2, I have 1 over 4 plus 1 over 12, which gives me also 3. Now I'm going to combine R2 and EQ1 into 1, and EQ2 and 7 into 1. So I call the combination of R2 and EQ1 in series EQ3, and EQ2 and R7 in series is EQ4. Since they're in series, I just need to add them together. Okay, so I redrew it, and I have EQ3 being 6. I did that by adding R2 and EQ1, and EQ4 is 5. I'm going to update my table now over here so that I have all these EQs in there. I have one last thing to combine, and that's make EQ3 and EQ4 into one resistor. So these two up here can be combined and made into one, and then I will have a very simple circuit that just has 2 resistors in series. Okay, I went ahead and calculated what it would be like if I joined EQ3 and 4 together and made them into one resistor, and that would just be 1 over 1/6 plus 1/5, which gives me 2.73. I'm going to add these to my table. There's only one thing left to do now, and that's figure out what is the total resistance. Total resistance, R total, would just be made up of R1 and EQ5. If we add those two together, it's going to be R1 is 3 and EQ5 is 2.73. So that's going to give me 5.73. Okay, I've got my total resistance in the table, and I can put my total current in, which is in the picture, that it's 18 volts. So I can use V equals IR, because I now know V is 18, and I know R is 5.73, so I can find I. So by dividing 18 by 5.73, I'll know the current. The current turned out to be 3.1 amps. So if I look back at my pictures now, right here, if there's 3.1 amps in the total current, then there's 3.1 amps going through both of these. So I can fill that in now and put 3.1 amps in R1 and in EQ5. I now know 2 out of 3 squares. I can find the voltage in each of those by multiplying them together. I have the voltage calculated for EQ5, and what that tells me is EQ5 right here is really made up of these two. So in parallel, voltages are the same. So I can fill in that voltage of 8.5 for both EQ4 and EQ3. So 8.5 goes here and here. Now, again, I know 2 out of 3, so I can now figure out what those currents are. If you put that in the calculator, 8.5 divided by 5 is 1.7, and 8.5 divided by 6 is 1.4. Right, now I just found the currents. I now know the current through EQ4 is 1.7. Now look at this right here. Current through EQ4 is 1.7, which EQ4 is made up of these two. So EQ4's current is the same current that is going through these. So what is EQ4's current? 1.7? So then 1.7 is what's going through both of these. So I can go over and fill in 1.7 amps for EQ2 and R7. So this is 1.7, and this one up here, 7, is 1.7. Same thing goes for EQ3. I know the current through EQ3. I've just found it as 1.4. This current here, follow it, is this current through both of these. So whatever the current through EQ3 is also the current through 2 and EQ1. So now I can fill in R2 is EQ3's 1.4, and I can fill in EQ1 is 1.4. I now know 2 out of 3 for both of those. For all 4 of those, I can now calculate what their voltages are. I went ahead and did V equals IR for those 4, and I filled in the proper voltages for those that were blank. Now, I just found EQ2's voltage is 5.1. Now what does that tell me? Over here, EQ2's voltage is 5.1. Look at my original drawing. What was EQ2? It was these. That means that the voltage right here, or EQ2 is these. The voltage right here is 5.1. So I'm going to go into my chart and do R3 and R4, and I'm going to fill in their voltages the same as EQ2's, 5.1. So R3 and R4's voltages are 5.1. And if you look at EQ1, it is these two, 5 and 6. So whatever the voltage is of EQ1, which is 4.2, 4.2 is going to be the voltage for both 5 and 6. So I can take and fill in 4.2 volts for 5 and 6. All I have left to do is do V equals IR, solve for I, and fill in these right here. And then I know the current and the resistance of every single circuit, or every resistor in the circuit. The table is complete. I calculated the currents. Now if we want to check it to make sure things are making sense, you know that the currents must add up to the total current when they split in a parallel. So if I look right here, at this point right here, where they split and they go up and down, how much current is there coming into this resistor? Well, this is the total current of the whole circuit, which is right here, 3.1. That means that 3.1 goes this way and this way. Well, if I look at these two, and I go back to my last drawing, right over here, I see it splits into 2. What does EQ3's current and EQ4's current add up to? EQ3's current is 1.4, EQ4's current is 1.7, 1.4 and 1.7 is 3.1. So the 3.1 amps splits and goes that way. And it should make sense that if you look at the two resistances for 3 and 4, one is 6 and one is 5. The 5 is less resistance, and if you look, it gets a little more current than the 6. Another spot that is interesting is right here. If I look at this used to be called EQ2. We called that EQ2. What is the current going through EQ2? If I look at EQ2, look at the current, it's 1.7. That means 1.7 amps goes through here, but it splits into R3 and R4. Well, let's check R3 and R4. R3 is 1.3 amps, R4 is 0.4 amps. EQ2, 1.7. If you add these two together, you get 1.7, which means right when it encounters this split, some of the current will go this way, some will go this way, but it all adds up to 1.7. if you look at the two resistors, this is a 4. A 4 ohm resistor only gets takes 1.3 amps, but the 12 ohm resistor is higher, so it only gets 0.4. But together, you get EQ2's current going through this combination. So that's it. Hopefully you can rewind, pause if you need to, and work at your own pace and get all this to make sense.